Hey guys, we're gonna do the whole arc link thing with radians. So in class, the last couple days I've done stuff about arc length when using degrees. Now we're going to use radians. Now the thing of it is, this really isn't that different. The basic layout of the setup is the same. You're taking the central angle. Well, I think today when I did arc length over circumference equals central angle over, now this is where it's different. It's not 360, it's 2 pi. That's the only difference in this, where we're doing it with degrees as opposed to radians. So they want to know the arc length. So that's the thing we don't know. They're calling it S, but I'm going to call it L for length. The circumference, well, the radius is 5, so the circumference is 10 pi. Remember, 2 pi r. Now this is really where the angle is 0.4. This is where radians really can shine, because the pi's make our lives easy. Now again, how many times have I told you how to solve a problem like this? What am I doing? Okay, you multiply by your two denominators. So over here, I get 2 pi L, and because the 10 pi's cancel, the 2 pi's cancel, I get basically 4 pi. And now, when I divide by the 2 pi, the 2 pi's cancel out, and I get the length to just be 2. And so this is where radians can really shine, because a lot of these problems, when they would come out ugly, now are going to come out nice because we're dealing in radians. So again, remember this little setup, because I don't want to have to write it every single time. But basically, remember what you're doing. Every single time when you're talking about arc length, you're setting up the same measurement. So you're saying the arc length to the circumference equals the angle to 2 pi. So the arc length is the thing I don't know. The radius, the circumference here is literally 2 pi r, because they told me that's r. And then the angle is 1.2 is to 2 pi. Now, I'm going to go back and look at this question, but it appears they're wanting an answer with a variable in it. Yeah, see, it says in terms of, write the length in terms of r. So they definitely want an r in my answer. Now, here's a way to think about this that's even easier. Notice these both are in the bottom of the fractions. They literally can cancel out right now, and they're just gone. So now if I multiply both sides by r, I get L equals 1.2 r. So that's the answer I'm looking at. Again, they use their variable to be s. I don't like s's. They look like 5s. So 1.2 r. All right. Here we go again. Same idea. We're talking about wanting to find out here. They want to find the circumference. Write the fraction of the circumference. Now again, an arc subtends, so we're gonna deal with this problem. Okay, so we're gonna do. Remember, I'm gonna write it in another time. The arc length to the circumference equals the angle to 2 pi. Arc length, I don't know. What fraction of the circumference is this arc? Arc length. Circumference is 2 pi r. Angle is 2 pi over 3 over 2 pi. So again, these cancel out. So you get L equals 2 pi. Now, it says what fraction of the circumference is the arc? Well, that's the length of the arc. What fraction of the circumference that is then to divide that by 2 pi r. Because so you're taking my arc length and you're dividing it by 2 pi r. And these things completely cancel out. And so the answer is 1/3. Last one. That one's a little difficult, but this generic ones are a little bit harder. Okay, I think we're not gonna have a generic one this time. We're gonna be a little more specific. So again, for the fourth time, the arc length divided by the circumference equals the angle divided by 2 pi. So the arc length is 6. The circumference is 8 pi, because double that, equals the angle over 2 pi. Now, you can completely reduce, or for nothing else, but you can definitely, if you don't know what else to do, these pi's definitely cancel out. Now I multiply both sides by my denominators. The 8's cancel, so I'm left with 12. The 2's cancel, so I get this. And so then my degree measure, my radian measure is 12/8, which reduces to 3/2. There we go. So that's another one. A little more difficult that one is. You may have to look at that a couple times. Always ask questions, remember.